Okay, good morning. This time I'll remember to push play on the video before I start. So second time through, and it is only 8:30. Okay, 4.4, next section of the textbook. The difference here is our leading coefficient is not 1. It's the same process, but just a couple extra steps. So I'm going to do about 4 examples and then give you some homework. So again, anytime you look at any expression, first make sure you can't pull a common factor out. I can't pull anything out here because 3, 11, and 6 don't have a common factor. I can't pull a variable out because I have x squared, x, and no x. So right now it would look like I couldn't factor this. However, if we use the method of decomposition, which is what I'm going to explain, you can actually factor it. It is very similar to what we did last lesson. You're looking for things that multiply to the outside. So I'm looking for something that multiplies to positive 18 and adds to positive 11. Multiplies to the outside, adds to the inside. So what do I have? I've got 1 and 18, 2 and 9, 3 and 6, I'm halfway, 6 and 3, 9 and 2, 18 and 1. Which of these combinations adds up to a positive 11? That one works, so let's start there. Now, with decomposition, because when things decompose, they break down, what you're actually going to do is you're going to break down this middle term. It has to be mathematically equivalent, but you could write 9x plus 2x, right? 9x plus 2x is the same as 11x. So I've broken down that 11x into smaller pieces. They are mathematically equivalent. They are the same, but they're smaller pieces. And once you've done that, what you would do is you would split this equation in half, right? So right now we won't focus on this. We're actually going to work on, I could use a ruler, that would be better. I'm actually going to work on this part of the equation right now. So, and I'm just going to work on this. I take a look at 3x squared plus 9x, because it was positive 9, and I'd say, okay, what factor can I pull out of there? Well, 3 and 9 have a common factor. I can pull a factor of 3 out. I have an x squared and I have an x. So I can actually pull out an x from that term. Okay, now I look at factoring this, putting the brackets in, saying, what would I have to multiply 3x by to get back to 3x squared? Well, the answer would be x. 3x times x equals 3x squared. And what would I have to multiply 3x by to get to 9 plus 3? So I factored the first part of my equation. Okay. Then I'm going to factor the second part of my equation. I have 2x plus 6. So I look at the 2 and the 6. I can pull a factor of 2 out. What would I have to multiply 2 by to get back to 2x? I'd have to multiply it by x. What would I have to multiply 2 by to get 6? It would be 3. So this is going to be a positive 2 because positive 2 times positive x equals positive 2x, and positive 2 times positive 3 equals 6. Now what I take a look at is inside the bracket, I have the exact same expression. That means that's a common factor, and I can pull that common factor of x plus 3 out in front. When I pull x plus 3 out in front, what am I left with? I'm left with 3x plus 2. And that is the factored form of that quadratic. How do I check if it's right? Well, I go back and I use good old FOIL. First, outside, inside, last. I get x times 3x equals 3x squared. Outside, x times 2 is plus 2x. Inside, 3 times 3x is 9x. And last, 3 times 2 is 6. Here are my like terms. And I'm left with 3x squared plus 11x plus 6, which is exactly what I started with, so I know I did it right. Remember, this is just checking your work, so don't show me that. And also remember, you've got to put your equal signs in there for communication marks. So just extra step, you've got to decompose that middle term, and then you need to factor it and collect the factors. Now, a lot of you would say, which is a really good question, you're like, well, how did you know to put the 9 first and the 2 second? And the answer is, it doesn't matter. But if I have 9 and 2, if I put the 9 here, I'd be like, oh, 9 and 3 go well together, because I always know that I have to split it up into 2. So 9 and 3 go well together, and 2 and 6 go well together because they have common factors. I could, however, have just put 2x and 9x together. And I should still get the same answer if I've done it correctly. Again, 2x and 9x is equivalent to 11x. So all I'm doing is I'm breaking up that middle term. And if I split it in half, I would look at this and I would say, oh, 3 and 2, can't pull a factor out there. But I have x squared and x, so I could pull a factor of x out. If I pull a factor of x out, I'm left with 3x plus 2. Over here, I have 9 and 6. The greatest common factor is 3. I can't pull any variable out, and I'm left with 3x plus 2. So again, I still have the same inside bracket, which means that it's a common factor. I can pull it out in front. And what am I left with? I'm left with x, and here's my invisible positive, remember? Plus 3 times positive 3 times positive 3x equals positive 9x, so that's going to be this. If you take a look at this, this is the commutative property, which is just a fancy way for saying a times b equals b times a. When things are multiplied together, the order in which they're multiplied doesn't matter, so this is exactly the same answer as that. It doesn't matter whether you put 9x 2x or 2x 9x, provided you do all the steps correctly and provided they're the right numbers, you're going to get the right answer. Okay, so that's all there is to factoring quadratics. Do a couple more examples. Okay, let's look at a second example. In this case, I'm looking for two numbers that multiply to -20 and add to -8. So 1 and 20, 2 and 10, 3 doesn't work, 4 and 5, therefore I'm now halfway, let's write them backwards. Okay, because this number is negative, I'm gonna make my left-hand column negative. Therefore the product of all of these combinations is gonna be negative. So now all I have to do is look for the one that adds to -8. That's gonna be my correct order. So now I'm gonna decompose my middle term. And when I look at it, I can do 10 and 2, which is okay, but the 2 and the 5 don't work so well together. So instead of doing 10 and 2, I'm gonna do 2 and 10. Again, it doesn't matter as long as the numbers are right. Okay, so I've decomposed. Now I'm gonna split my equation in half. I'm gonna pull a common factor out here. I can pull out a 2 and I can pull out an x. So if I pull out 2x, what would I have to multiply 2x by to get back to 4x squared? It would be 2x plus 1. Okay, over here I have 10 and 5. The only factor I can pull out there is 5. Remembering that I need to get the exact same brackets in here, right? If I don't have the same brackets, I can't pull them out in front. So when you do decomposition, as soon as you find this first bracket, the second bracket is supposed to be exactly the same. And if it's not, you know you've made a mistake. So then I would say, okay, fine, I've got to have 5 times 2x equals 10x, but I don't need 10x. I need negative 10x, so I have to have negative 5 there. Let's just check, does that work? Negative 5 times 2x equals negative 10x. Negative 5 times positive 1 equals negative 5, so that's great. I now have two brackets are the same. I can pull them out in front. I have 2x plus 1, and what do I have left over? 2x minus 5. Put in my equal signs, and I've actually factored that using decomposition. Okay, let's do one more example. I have 2x squared plus x minus 6. So I'm looking for two numbers that multiply to -12 and add to positive 1. So 1 and 12, 2 and 6, 3 and 4. I'm halfway because those numbers are beside each other. 4 and 3, 6 and 2, 12 and 1. You see, once you get halfway, you're just taking these and flipping them around, so that makes it fast. Because this is a negative number, I'm going to make my left-hand column negative, and now all I have to do is look for the combination that adds to positive 1. This is the only one that adds to positive 1. Okay, -3 times positive 4 equals -12, and -3 plus positive 4 equals positive 1. So let's rewrite this, decomposing my middle terms. Again, I could put -3, 4, but 2 and 3 don't really work together so well. So I'm actually going to put positive 4x minus 3x, simply because I know, I'm just thinking ahead, 3 and 6 go nicely together and 2 and 4 go nicely together. If you did it the other way, you'd still get the right answer. Okay, so just double check. I've decomposed my term. Positive 4x minus 3x is the same as 1x, so that's okay. So let's split this in half. What can I pull out of here? I can pull out a 2x. If I pull out a 2x, I'm left with x plus 2. What should go in this bracket? Well, the whole point is that you make the brackets the same. I should end up with x plus 2 there. What would I have to put in here to make this true? What times x equals negative 3x? The answer is negative 3. Let's just double check. Negative 3 times x equals negative 3x. Negative 3 times positive 2 equals negative 6, and I'm done. This bracket is the same as this bracket. I can pull those out in front. So I'm left with x plus 2. When I pull out x plus 2 in front, I'm left with 2x minus 3, equal signs, and you factored your quadratic. Okay, that's it for me for today. I really hope this video pushed play. Homework today from your textbook, page 223, 5, 6, 7, 11, and 14. I'll also post full solutions to those questions. Have a good day. Bye.